Hi everyone, welcome to the presentation. What I'm going to talk about is the migration. It's more like an experience talk, the decisions that we made and the kind of things that you run into when you migrate the data warehouse to the cloud. It's by no means the way to actually do it. It's very much also been finding your way, finding your path kind of experience for us as well. So first of all, this is the team who did it actually. This is taken at one of the cool blue parties that we do, where the whole company just dresses up in their own theme with a different team. So that was a very good way of actually releasing some steam. And some more information about me. I'm in BI since 2016 only. Before I did a lot of software engineering, had a drone company in Brazil. And besides that, I'm also an artist, oil painter. This one was done at a workshop in Florence and one of the art academies over there. So that's also a really great way for me to do something that's completely different. So once upon a time, a little bit of context. The first thing I'm going to show you is a little bit about what the challenge was that we had to do and the kind of thing that we had to move into, right? So the data center architecture that we have is that we have quite a large number of sources to take data from. So one of them is the large OLAP database. We are a retailer, so we have a lot of transactional data, invoices, orders, but we also do all the shipments and all the deliveries. We have our own delivery van network across the Netherlands that we actually also take some data from, market share data, Google Analytics, marketing data, so all kinds of things that go into the data warehouse. We are using SQL Server for it. In terms of size, you need to think about 1.5 to 2 terabytes of total amount in all the databases. It's a typical system of putting things into the staging first, and from the staging that we take from all the external sources, we build our facts and then we put it into data marts. And then eventually we make them available in OLAP cubes on the SQL Server, and we have about 300 users connected to that. So that's quite a significant network and things that you have to deal with when you take on these kind of migrations, because as soon when you migrate things away, users will also have to update their Excel spreadsheets, because typically Excel is being used for contact in the cubes. At the same time, we are moving to a different infrastructure built on Google BigQuery for the data warehouse. That's just because the SQL Server is becoming too limited and constrained in these things. But the strategy was to first move from on-prem to the cloud, and then on the cloud it is much easier to build things in different ways and scale out or scale down. And so that's one of the things that we decided, because we had two decisions to take: or we're going to renew our metal servers for another 3 years, or we're going to just push everything to the cloud and then still have the metal servers for 1 year in extended warranty. So it was actually getting close to the extended warranty for the machines. All of the scheduling that we did at that time was done in Azkaban. Azkaban is a scheduler that it was built originally by LinkedIn, and it works. It's more like a very well, how to say that, a very rich cron, but at the same time you need to build a lot of custom source code in order to run that, and that has been given some problems, especially when you want to do a little bit more things. It becomes more difficult to reuse some of the code that you're building in other ways. So this whole middle system went to AWS. The cubes also went to AWS. And we migrated the scheduling system from Azkaban to Airflow, and then from Airflow it was also going to AWS in the end, right? So this is the whole migration steps I'm going to talk you through. Moving away from Azkaban and adopting Airflow. And the other one is about SQL Server going to the cloud. That was also something to deal with, because you're going to, it's still SQL Server, but it actually works quite differently. And the OLAP Server from data center to cloud as well, which had some issues with all the users and the load balancers, and some validation mechanisms below that, because the decision for us to actually move to the cloud meant that we were able to run things in parallel. So that means that you can do validation from your official production warehouse to something that you run as a shadow production on the cloud, and that can make it a lot easier to figure out where things are going wrong. So escaping Azkaban, that means that first we're going to try to go to Airflow and get some of the old technical debt out, because the whole system was built in a company that had growth of 40 to 60% per year. That means that you have a lot of different data analysis questions that you have to deal with in order to keep the costs relatively low, right? Because otherwise you don't exactly know where and how you need to spend your money. So Azkaban versus Airflow, what is the difference here? Azkaban has some configuration that's separate from the code. You have to do a lot of manual coding, and basically what it does, it triggers your jobs only, and it doesn't really help you a lot in terms of making a system that is based on components that you can reuse. Rerunning the individual tasks was complicated because the size of the schedule that we had did not allow us anymore to just rerun it as a dependency based, but you just had to rerun the whole thing entirely, and it just didn't work anymore. So that was giving us some usual problems when there were some data issues. And the interface isn't really great if you really want to do some analysis on what went wrong and for what reason. You can easily look into the log files, but you don't really see the schedule that we have. I'll show you the reasons why that was, mostly technical debt. And in Airflow, what we had is that you get a lot of interesting abilities. For example, dates that are very useful when you do incremental loads. You can actually use them as part of the platform. You can use macros from the platform to ingest that or put that into the scripts, so that in the script itself you can play around with those dates to do things on the basis of the run that you're doing. We're doing daily runs in this case. So those are the templated arguments, and we had a lot of building blocks. They're called the operators. So moving things from Oracle to SQL Server, or doing things on SQL Server, you would have some standard building blocks to allow you to do that and put that into the workflow itself. So there's a lot of benefits for us to use Airflow. And then one of the questions was about what do you need to migrate? Because I'm talking about a database, and at the same time when we are running the data warehouse, there are many different teams in Coolblue that are actually rebuilding things in different ways, for example on BigQuery. And especially marketing has removed a lot of the dependencies on the SQL Server and rebuilt everything on BigQuery. So in the end, a lot of those things didn't really need to be migrated anymore. So if you didn't check that, you would be doing a lot of effort for completely zero. So that's one of the important things to look at about what exactly needs to be migrated for what purpose. So then you have a really good idea of trying to diminish the work and get rid of the old stuff that can sometimes be not very well built, right? So this is the big daily process. This is the conceptual overview of what it looked like. It was actually 1,000 tasks in one big graph. So I can show the actual diagram, but it will sort of look like this. It wasn't visible and displayable on a monitor anymore, so the only way to go through it was through a tree view, and that was making it really difficult to understand how all these tasks fit together and where they go. So as part of the migration process, what we really wanted to do was to also simplify this and to take apart the complexity in this Azkaban structure and to redo that in a different way on Airflow, so that we still are able to keep an overview of what it is doing, and that we also see hierarchically how it is built up. So this is the whole process of doing that. The papers that you see over there, they're basically the diagrams that are created as graphs, and then through those graphs we analyze it, we figure out which tables are there, how they are built, the underlying SQL, and then from that we figure out if maybe some of that needs to be simplified and changed, or if it just migrated along as it is. And there's about 1,000 tasks in the whole flow, actually separate different flows, and that well, can be quite a challenge in order to figure out how to migrate that. In one of the monitors here, you see, for example, on an Airflow diagram, how that turns out. And what we actually did was we are creating multiple pipelines instead of one. So instead of one big pipeline of moving the data, we are now creating one for doing the staging. We're doing one for doing the fact tables and some other processing. We're doing one for all the heavy calculations, and we're doing one for all the cube updates. And it means that you can go into each one and have some different scheduling setup, and you can create interdependent communications between them. So one DAG can wait for the finishing of another DAG and then move on. And that means that you have also some multiple checkpoints. For example, staging needs to finish in order for other phases to continue. And that means that if you have a large diagram or workflow that actually looks at individual tables, then if you have those checkpoints in place and something fails, it can have some additional impacts on some other things that could have proceeded because they're not dependent on it. So those are some of the things that we had to look at and make some sensible checkpoints in there. So this is what the time basically looks like. At the moment, it's now taking about 1 hour for loading all the staging data. That's about 325 tasks. We do some heavy calculations, roughly about 50 tasks. Loading all the data warehouse tables, so those are the fact tables, the things that we really want to have in the warehouse. And the semantic layer is basically OLAPs in the cube, and that's about 20 tasks for updating the dimensions, and then from the dimensions, the facts, and making sure that all the data is ready. That required us also to look a little bit into the API of the Cube server as such, because the way how it was done originally wasn't the best way to do it. So we actually rebuilt that a little bit to process the indexes and then or index the data and do those two steps separately. So the checkpoints approach, as I said, is can be a little bit slower because you have it's a bit like as if you do something first and then you have one point, and then from that little node you go out again to multiple tasks, and let's say it becomes a little bit easier to manage, but and it is more maintainable, but you have some more impact because if something fails, it is not that good. So this is one of the things that we also were having to look at, because from the source to staging, we have a lot of components that were used, in our case Oracle, MS SQL, for example, one of those operators, and they were actually new building blocks. We hadn't really used them a lot, so there's a lot of things that can go wrong, especially because of speed concerns. We were used to use BCP. BCP is a command line utility for SQL Server that is very fast in data loading, but it is not very permissible in the kind of what the data needs to look like. And when you get failures, you get a very mystical error. So we spent quite some time on that. And this is the kind of code that you would get in Azkaban. As I said, it's just, Azkaban is like a trigger, it's a very rich cron. And it works, but inside all of this code, you can also see that there wasn't a lot of, how to say that, you don't see, for example, connections being set up. And that was because all the utility libraries that were built were doing that under the covers. So on the basis of the name of the file that you want to execute, it would connect to a particular database. So all of those hidden behaviors made it more difficult to also migrate to something else in the future. And what we replaced that with are the default Airflow operators that sort of look like this. You have the connection IDs, they go to a particular database, you run a particular query, and then the data gets migrated to the other side, and that's it, basically. But because of the operator or being new and these building blocks being not used a lot, we still had to inspect if those things were doing the right thing, and we would often see some kind of failures because of that. So what we now have is the configuration as code. So all of the things that we have in Airflow is coded. There's no external configuration files, for example. There's less code to maintain because we're able to dump away all those utility libraries and the specific code that you have in place if you only have a trigger for some of those jobs. And the custom code is just rare. So we have some very building blocks that are configurable by just adding some parameters, and that means they are more reusable, and it is much easier to see where things are happening and how they are happening. So we are now able to create pipelines a lot quicker and a lot easier. So that's the same thing basically, and now we have a manageable data process. So that was one part of the migration done, migrating from Azkaban to Airflow, which I think for us has been a really cool effort to also try to reduce some of the complexity and to be able to rerun these daily runs on a daily basis a lot easier. The SQL Server is the next bit, so that's this part. We are running now things on Airflow on the new SQL Server. These were initiated around the same time because you need to, of course, have an SQL Server to deal with, but we started with a very small one because we started to focus on the staging layer first. So you have this metal server, and then at the same time in Amazon you have these RDS servers. They look really cool and really easy to use, and in fact they are, but it is different to use them. In one of the pictures you see the guy in the back, he was the SQL Server expert. He's basically the DBA, and he has been well, dealing with a number of things that you don't have available in RDS, but that you do have on the physical servers. And one of them is, for example, monitoring. So the first thing you have to do is to think about how do you want to set this up, because the first thing in RDS is that you want to be able to have a server created, and that's quite easy. We do everything CloudFormation, so the company has a hosting and deployment team, and the hosting and deployment team, they create this infrastructure for us, and they also have the best practices to follow. So it's not like we can just say, let's just spin one up from the user interface and that's it, but you have to go through CloudFormation to do everything, because everything that we do has to be in code and configured in code. So, and I think that's a good concept, but it does take a little bit of time to learn CloudFormation and the kind of impact that you have on those different parameters that you have in AWS. So the good side is that when you have it in RDS and it is working, all the patches and all the backing up and all those things, they happen automatically. But backing up is slightly differently, because on a local SQL server, you would typically do a backup of the database as a file on a file system. But the backup on RDS, for example, is the whole volume, so the underlying volume of where the databases are kept on the file on the disk. It's actually a network disk. So this is how that worked. We first created our own instance on RDS through CloudFormation. Then that's, you get a couple of different parameters. With some of those parameters, if you change them, you have to recreate the whole instance. So then you have to reload everything and go through that process. But when you choose something that is quite reasonable, that doesn't happen. And the DB instance class is in this case the small one, but eventually we went to a much larger one that was more suitable for our whole system. But you do that only near the end of the migration, because otherwise you start to pay quite a hefty sum in license fees and instance fees, of course. So there you can choose all the configuration of it. What we had to do was basically deploy our data warehouse schema onto it. So everything that we do is in code. So that means also through TeamCity, which is a deployment tool, we are then retargeting that from GitHub to the SQL Server, so that all the schema gets created and all the users and everything. We are using a plugin for TeamCity called Redgate for that. And Redgate basically reads the schema, looks at the target, resolves the differences, and then makes sure that the target is as you specify in the source. And we had some historical tables. Examples of that are incremental tables, fact tables where you are adding records on a daily basis, and because the source changes afterwards, you're not able to recreate those tables from the source directly. So what we had to do was to push those tables from our on-prem environment, the data center, to RDS as well, and we ended up using SSIS for that on the production server, which was a lot easier for us, because otherwise you have to do this through Airflow and spend a lot more time on that. And it was easier and it was faster, because you don't go through another hop of one server in order to do that. The daily ETL and Airflow was then also changed, so that we are able to run this in parallel. The old environment was still running on Azkaban and on-prem data server, but the new environment in AWS was being pushed through Airflow, so that you have already starting to get two parallel environments. And we are using some data validation tools for that in order to look at the differences between them. And I'll talk more about data validation later. These ones are the NBI and Apache Beam. So what is the benefit of being on RDS? We can easily scale the instance. We have done that before. So we started with a relatively small one, but then we noticed that as we started to do more of the heavy calculations, we had to upgrade. And eventually, when we are now migrated on SQL Server on AWS, we're going to migrate those data products back to BigQuery. We'll be able to downscale this instance quite easily, and that should give us a lot more flexibility in getting this done. There's no server maintenance that you have to think about, so the DBA didn't really have any kind of concerns there. The only thing is that the way how things work in Amazon is a little bit different, especially when you think about making the backups, restoring them, and the kind of things that you have to do in your CloudFormation, because there's a particular sequence that you have to follow. So that took quite a little bit of time to figure that out. And because it is in CloudFormation, all the configuration is in the code, and the backup mechanism, as I said, needs to be researched a little bit. I think we took about a month in order to figure out if those are the things that we wanted to do. Also because one of the things in SQL Server is that you have to join an Active Directory domain. Active Directory domain allows the end users and the cubes to connect to those services. If you don't have them on AWS, you can't authenticate. And what we found out was that there was a bug that when you recreate the instance, it doesn't join the domain. It doesn't happen for some reason. And then only after 5 hours, it does a rollback. So there's a couple of issues that you will encounter through this process that you need to allocate some time for. It's not necessarily running out of the box, even if it is on AWS. So the next thing I'm going to talk about is the Cube server. The Cube server is the OLAP server where you have all the users connected, and it also had to go to the cloud. And this SaaS product from Microsoft, I think it is really good. It's very difficult to find a product that has equal functionality for end users. If you go look at Druid, for example, because then you think about Druid and the front-end tool and the end users that are not experts. So this is one of the things that we also wanted to migrate for now and not have to concern about this as yet another thing in the whole migration process, because it would be too much for a team of 5 people. So an OLAP database is basically online analytical processing. It's where you do the slicing and dicing of the data. And the biggest number of people that are using this are in the category teams. So those are the people in our retail environment that work with the specific categories in our product database. So for example, televisions, kitchen equipment, and what they do and use it for is to see what the range of products are that we are offering, how they're being sold, how they can reduce and improve the offering that we have, that we don't have too many products of a particular type that are very comparable, but that we have some really good products that don't get returned, and then also look at seeing if they can meet the targets that they are setting with the board, for example. So it's mostly for end users. When you have these queries or these interactions with the Cube server, the people that are using the Excel spreadsheet are actually also importing a model. So if you want to migrate away from an OLAP server, you need to take into account that if there are people that are using this for about 6 or 8 years, that they have, I think we saw something like 30 gigabytes of Excel spreadsheets in total that we had to migrate. So we used a folder in order to do that, where the URLs in order to connect to the Cube server was updated. And it was quite a significant effort, because there's a lot of coordination and a lot of things that you have to deal with. And if you don't put it as part of the migration effort, it's easily going to take something like 3 or 4 months to figure out. So the question was basically how we do that, because the technology is not the same as SQL Server. There is no specific RDS or AWS ready product for this. So one of the questions then becomes, you have this meta server where you install this software that isn't necessarily cloud ready, and then how are you going to run that? Well, obviously the question becomes, you want to run this on EC2, because there is no RDS on that, so that's what you need to use. But in order to do that, you need to own that as well, because every team in tech that we have at the company, they are owning all the infrastructure. We don't have a special operations team that would say just do deployment of these servers. So when you have something in the cloud, you own your own stack. They might build it for you initially, but then eventually you end up owning it, tweaking it and configuring it for your needs. But it also meant that in this case, we had to create and install the SQL server and do all the Active Directory joining and all the setup for that. And that was quite some effort, because the people that we were working with, a lot of them didn't really have any AWS CloudFormation knowledge or the knowledge in order to provision these machines. So as part of the best practices, when you run EC2 instances on AWS, AWS itself recommends that you do a weekly recycling of all your instances. So that means you can't just create an instance of EC2 that is running through the user interface and leave it running for 3 years. Every week, all of those instances get downed, they get wiped, they create a new one, everything gets reinstalled, and then it runs. And the reason why you do that is because there are sometimes changes in AWS that are happening that can deprecate some APIs or deprecate some functionalities that you wouldn't become aware about. So, and it's also because of security. There's security updates on base boxes, as they call them, that you then would have to, it would make it is more difficult to apply the updates than just to create a new box and reinstall it on that one. So those are part of the best practices as well. So the first thing that we will do is those Amazon machine images, AMIs as they call it. What we do is we create a base box out of that. They are called base boxes for us. So we have a couple of standard things that we install on that, and we're using some provisioning languages like Ansible or Kitchen CI or the command prompt PowerShell in order to do that. Then what we do is we pick up that base box, and then we are using some other technologies, CloudFormation, and some other repositories in order to make them available for the rest of the installation process. In Octopus Deploy, we're going to join it to Active Directory and do some other PowerShell configuration provisioning stuff. And eventually, we're going to connect this to and update the Cube server using Airflow or restore the backup that we made. So it's quite a complicated process. This is something that took us about 3 months to really get done and sorted out. And it was quite a complicated step because we also had a load balancer that has a certain time limit of 1 hour. And if you're updating data, it is possible that updating a whole cube, you're going to take about 2 to 3 hours. So then you don't get the feedback anymore if that update on the cube actually worked or not. So that's one of the things also with the partitions that you have to do. Also in Airflow, figure out what needs to be refreshed in the server, creating the partitions. So those are other things in Airflow that we had to figure out and work out and schedule, and in order to get that working on the cloud. So that was quite interesting. And we, of course, when you do all this work, you use the components from Airflow in order to do that. Those are the standard operators that you build once, and then reconfigure and then apply again. So then the users had to be migrated. So as I said, we made a tool for that so that it could drop all their spreadsheets with all the cube connections or the cube models that they had, and they could drop that into a folder. And then in another folder on the other end, we would dump the migrated spreadsheets. And that whole process, because we were running that from a single desktop, was taking quite some considerable amount of time. You would have to download it over the network, process it locally, and then upload it over the network again. And when you're talking about gigabytes of data, it's going to take a little while. So this was something that took, I think, about 4 weeks or 5 weeks in total in order to get all those spreadsheets migrated for all the spreadsheets that the users cared about. And we had no idea what was in there. Some of them couldn't be migrated, so then we had to reserve some time with one of the people in the team to sit together with other people to see what was in those spreadsheets, if it was doable to actually migrate that directly, or that they had to change the model and do something else. So that's quite a significant effort as well. So what we have now with the OLAP server is we can easily scale that instance as well. We can increase the disk size quite easily. It's something that gets rebuilt every day. And the good thing about it is that it sounds like a complicated thing that can break easily, but it hasn't broken since, let's say, 1 week after or 1 month after the migration. There were a couple of issues in the beginning, but afterwards it has been running for about 7 months, and we haven't had to look into it for, at any point of time in that. So it's a very consistent process. And we are also making backups on a daily basis in a very consistent way. So that means that if there's any kind of failure, we can easily go back to one of the backups, restore a new machine, and get things going again. And the load balancers, as I said, was a very specific problem because they work really well, but they have those limitations that up to 1 hour or something, and then the connection gets dropped, and then you don't get the feedback, and the tool that you use locally in order to connect to them will also have that same issue. So those are the things that you would have to think about if you deal with this technology. The validation, what we are doing now is actually making sure that all the data that we have on our site is the same. And what we did was actually first, we were going to validate the source. So the source validation is from the source systems, and then we were making sure that the data as it looks there on Oracle in a number of cases was the same on SQL Server. And what we did was that we were making selections on the database ordered by the primary key in order to make sure that for the first 10,000 or 100,000 records, you would be getting the same data. And in order to do that, we didn't actually take all the data, but we just compute hashes from all the columns, or the columns that we have in the target database. We would automate this process as well from a DAG, and then from those hashes, we can compare them together. With the hash, you need to make sure that you have the same hash algorithm on the source and the same hash algorithm on the target. And also with the spaces and other things, you have to figure a couple of things out. And if there are hashes that are not matching, then those rows are for some reason different. You don't know yet what, but you can look into that at a later time. So that's basically what we were doing, and we ended up using Apache Beam for that, but that wasn't more like an arbitrary choice. There's not a lot of data in there that would not make it feasible to run on a normal Java or any kind of other project. So what we were able to identify is what is not in the source, what is not in the target, and where they are different. And that would allow us to do an analysis over all the tables, 325 on a daily basis, to see where the differences are. Because if you need to do manual validation to go into the tables, you're probably going to miss a lot. You're going to spend a lot of time doing that. So we had an automated validation thing in place. So we had a group out of the output. We put it in an Excel spreadsheet or in a Google Sheet, so that every day when you come in the morning, you can actually see where the differences are, if there's things in difference in staging and so on. And then the daily reports would look like this. So that's what you see, what was the value yesterday and what was it today. And there are some detailed tables that you would use where you can see where there was some issues with if they were equal, then we would just drop them. But if they were different or they were not present, we would actually see them in a detailed spreadsheet. So the whole validation step is get result from the source and the target. For the staging and the sources that were different systems. For the other validation that we would do on SQL Server, we would take the source as SQL Server on-prem in the data center and the target to be the one on AWS. We would also use the same approach, calculate the hashes, compare them, track the differences, and then we store the counts of the difference in the tracking tables so that every day you can see what the differences are. Custom validation is another thing that we did, which is more related to an NBI tool. That is a driven tool that you would have, a UI tool for on the user desktop. And there you can connect to the cubes as well. So with NBI, we were able to finish the full loop of testing to see what the people see on the cube in on-prem, on the data center, versus what the users would see in the cube on the old system, or on the new system on AWS. So that means that we had to come up with a couple of scripts that we could rerun from the desktop on a daily basis. And then in the same way, that would also have some kind of output where the differences would be located. So it's quite a handy tool to have that. And that's it. So where we are now, looking back to look forward. Well, we have built a lot. We have really scaled quite a large mountain of different things. We took a couple of decisions early on, and we stick with those, right? So that we didn't really change our path in the middle. But we do notice that we had done some work that we really didn't expect. I think that's quite usual that you would get. We were able to throw a lot of stuff that we weren't going to need anymore, so that's also quite useful. And well, we learned a lot in the whole process because we now know how AWS works, we know how SQL Server and RDS work and what the differences are. So that was a very interesting experience. The lessons learned is the things on AWS is quite different from as you would have it on-prem. So there's a little bit of learning involved there that you need to look into. You have a lot less monitoring capabilities. On-prem we had this tool called Redgate monitoring. And Redgate monitoring was giving us the ability to look at time frames overnight when we would have some difficult times for the server. You can analyze which queries that would be causing it. On RDS there is no such thing. Performance Insights is there, but it only has a top 10 of queries, and you can't really see how that works out, right? And we are doing two migrations in parallel effectively. All the SQL Server and all the old stuff together with Airflow. You can think about if that's the best way to do this, because otherwise we wouldn't have to do all the different validations so much. And also for the training for the AWS DevOps, we had a lot of things to learn about the AWS CloudFormation, the kitchen CI, and so on and so on. And the good thing is that now everything is more in code. So we used to have a couple of manual processes on-prem, but now everything is managed from an automated process somewhere. So that means that also in the future we'll be able to migrate things from what is done in the cloud and do that somewhere else, but because you also have S3 buckets and can easily copy data around. And this is more or less what the timeline looks like. So that's also seeing where we are gotten to. We started in March in 2018. We took a little bit of time for planning and figuring things out. We started migrating staging to September, and then we had all the Oracle problems, the validation issues to work out. And then eventually we went to migrating the facts, all the incremental fact tables and the SSIS. We had quite a large run for all the validation to figure out things, the SR spreadsheets, the cube users that we had to migrate, and we only ended somewhere in July, end of June. So that was the whole migration taken care of. So if you have any questions, then I'll be happy to answer them here, and otherwise in the speakers corner.